everyone, I'm King Robert Timula, a third-year PSN studying student of Caraga State University. So let's have an experiment, which is called Charles' Law. So what is Charles' Law, by the way? Charles' Law was formulated a French physicist, which is Jacques Alexandre Charles, who observed the relationship between the temperature and the volume at a constant pressure. According to Charles' law, temperature and volume is directly proportional to each other. At a constant pressure, since we are dealing with the hot and boiled water, the materials and equipment that we need in this experiment is
stove, kettle, glass jar, water, freezer, and balloon.
For safety reason, we use an
Eye protection, gloves, and lead gown.
health is wealth according to man. What are you doing here, King? I thought no, I'm not. Anyways, you're gonna hide to my experiment. Hi, experiment. So, let's get started.
So the first step we need to do is pour the water into the kettle. Then heat it up to the stove within 30 minutes. After boiling the water, transfer it to the glass jar. Then blow the balloon and put it to the glass jar and wait until the magic happens. As we observe, the balloon is bigger than its normal size. As we look in a different perspective, it's the same. The balloon will rapidly change when it's heated. Put the balloon in the table and let the balloon back to its normal size. Next, put the balloon into the freezer and leave it in a few hours. We notice it is smaller size, and as it warms, it's gradually increased in size. Charles' gas law states that when a fixed amount or mass of an ideal gas is kept to the constant pressure and in a closed system, then its temperature and volume are directly proportional. What this means is that temperature increased, volume increased. What is an ideal gas? An ideal gas is theoretical gas composed of a random moving, non-interacting particles. Under a normal condition, many gases such as hydrogen, oxygen, and some heavier gases like carbon dioxide will behave like an ideal gas. In our experiment, our balloon is filled with gases and air molecules. When the balloon is placed in the jar with the boiling water, the energy from a higher temperature water and stems molecules transfers to the lower temperature air molecules inside the balloon, exciting them. When the air molecules in the balloon is excited by raising their temperature, these is spread further and further apart, increasing the volume of the space they take up. The higher temperature or the more energy the air molecules they get, the larger balloon will grow, or in the other words, the greater volume. If we remove the balloon to the hot water, the air molecules inside the balloon will gradually lose the energy. They begin dropping back room temperature, causing the balloon to shrink in the volume back to its normal size. In the next part of the experiment, we place the balloon in the freezer, which causes transfer of energy and the form of heat in the warmer air molecules inside the balloon in a cold freezer. As the energy removed from the air molecules, they slow down, drop temperature closer and closer together, decreasing the volume of a space they take up. The colder the air molecules get, the closer together they will be. We remove our balloon into the freezer. The air molecules inside the balloon will gradually gain extra energy from the environment, raising the temperature, causing it back to its original size.
My experiment is simple yet practical that will help a lot of engineers and science-related jobs about this topic to make our world better. So that is my experiment for this topic with the Charles' Law on ideal gas. So, bye!